Not many golfers would like the idea of replacing their driver with an iron such as this, even in my very unprofessional manner. But you might well be forced to just such an arrangement if, for example, you left your clubs down in the basement for a considerable period of time, and then came back, picked up your favorite driver, and found that something had happened to it. On the underside, of course, all of that wood is gone. The wood is very hard. It's difficult to cut, even with a knife. Now, what has happened is that some insects, termites, have been having quite a feast. If you happen to be a homeowner, you will say that these are among your worst enemies. And actually, they're quite interesting creatures. And so, to tell us of the life, the habits of the termites, we have invited as our special guest on Science in Action, a distinguished scientist who comes to us from the University of California's Department of Biological Control, Dr. Richard Duff. How are you, Dick?
Fine, thank you, Earl. It's true that termites do cause millions of dollars worth of damage each year in this country, Earl. But termites aren't necessarily destructive. Some serve a very useful purpose in that they hasten the decay of dead wood in our forests. And I suppose that whether termites are good or bad depends largely upon what they happen to be eating at the moment. Of course, if you found galleries like these traversing timbers in your home, you certainly would have a very low opinion of termites.
That's a beautiful demonstration there. Incidentally, suppose, Dick, that we put this down here. By the way, how are you with an axe?
Well, I think I can miss your fingers and maybe your toes,
Let me get back here and get out of the way.
Well, let's hack into this, and maybe we can find some termites.
Now, there's quite a number of colonies working in there, so it may take a second or so.
I think there are some, and you see how quickly they go back into their galleries, which are not damaged. Now, if we just put that aside, they will wall over those galleries that we have damaged. And they do this not only to protect themselves, but also to maintain the humidity within the galleries where they live. Now, termites, like ants and like bees, are social insects, and that means that they have a division of labor within the community, so that probably it'll be the workers that will repair the damage that we have done to this log.
Suppose, Dick, that we look at the various casts that we have in the termite colony by means of these large models. Here is the worker that you just mentioned, a very nice little fellow. Coming over to this one, the soldier, the large head, and of course the expanded mandibles here. And then the all-important queen, the egg-laying machine of the colony. Then finally the winged form, or the reproductive form, which we see here.
Well, of course, Earl, the workers constitute the larger part of the colony, and it's rather interesting that most people believe that termites and ants are very closely related. But when we compare these two models, we can see they're quite different insects. Here, the termite, you see, has this soft body and this broadly joined abdomen. Actually, it's more closely related to roaches, probably, than it is to ants. And here, by comparison, the ant has a wasp-like body with a very narrow connection between the thorax and the abdomen. Actually, ants are probably the termite's worst enemy.
Well, there's one thing in which they resemble each other, and that is the matter of their industry. And when we look at a colony of termites, we see that the workers take care of the eggs and the young. Of course, they make the burrows and into the wood, and they also develop the galleries. They feed the queen and the king and the soldiers, who incidentally are not able to chew wood for themselves.
Well, now, when the termites are young, they look very much like this worker, and we call them nymphs. And however, out of every proportion of nymphs, a certain number will develop into this terminal caste, which we call the soldier, as you mentioned. And if something happens to the soldier, then more nymphs will develop into the soldier, and thereby they keep the proportions of the caste constant in the colony.
Of course, we have many different kinds of termites in the country. These models are of the dry wood type, which are found only in a part of the United States.
Well, perhaps we should point out that the soldier's primary function is to protect the colony, and you'll notice how the heads are particularly equipped for this. They have the very massive mandibles, very formidable-looking creatures, and they use these as sort of crushing weapons, you see.
Well, now, when this type of a soldier is attacked by an ant, those mandibles work like a pair of scissors. End of the ant. Now, if we examine some of these termite soldiers very, very carefully under high power, we'll perhaps be able to tease them with a pencil. And notice how those mandibles work now in coming towards the end of that pencil.
Yes, indeed. Now, other species have developed different weapons. Some of them have modified the mandibles and so they're very sharp instruments. And then we have in Central America a very interesting soldier which has its head prolonged into a tube-like structure. It uses sort of a chemical warfare in that it ejects from this tube a sticky substance which, applied to a small enemy like an ant, will pretty hopelessly entrap it.
Well, soldiers have other methods, of course, of protection. We talk about blockheads, but among the termites, there really are blockheads. Suppose we take this soldier model and place it over at this point, and right here is a break in the wall of the colony. And so this soldier comes to this position, puts his head through, and very effectively provides a method of keeping anything from coming into the colony.
That's right, and they are also capable of sounding an alarm. They do this either by clicking their mandibles together or by knocking their hard heads against the wall of the gallery when the colony is threatened with danger, you see.
I think, Dick, that the type of termite that we see most often are these winged forms, the reproductive, such as this we have right here.
Yes, these winged termites, Earl, will develop into the young kings and queens of new colonies. They are the royalty, really, of the termite community, and they only use their wings once, and that is when they set out to form new colonies. In certain seasons of the year, usually in the spring and in the autumn, these appear in great numbers, and many people are familiar with them. They have seen them, I'm quite certain, and these are the types that are often mistakenly referred to as white ants. Now, although their wings are quite large in proportion to their bodies, they're not really strong flyers, and they travel very short distances, really, unless they happen to be caught up in strong air currents which would carry them aloft maybe 2,000 feet or so.
One thing we should mention, Dick, and that is the matter of the eyes on the winged form. Now, the eyes are quite important because in the colony, they have no need of seeing light or darkness, but this enables the winged form to fly towards light. And that, of course, is very important in their life history.
Yes, and as soon as the flight is over, of course, termites lose their wings. Now, they do that because there is a weak section down here on the wing, and the wings come off very easily, are purposely removed by the termites, just in that fashion. And then,
this attraction to light is what you might call a one-time thing as far as the life history of the termite, the queens and the king.
That's right, and then their purpose is just to perpetuate the race, and so they seek a mate, and then they burrow into a piece of wood or an old log such as this, or even into the soil as the case may be. And then after a short time, the queen will lay her first clutch of eggs. It may consist of only about a dozen eggs to start with. And the young are tended by the young king and queen until the workers are old enough to take over the duties of the colony. And then the queen becomes nothing more than an animated egg-laying machine.
Well, I've heard some entomologists say that the queen termite is probably the most prolific among all the insects insofar as this egg-laying ability is concerned. Let's see, about 2,000 to 8,000 a day.
Oh, yes.
For a large queen such as this.
Yes, and because of her size, too, you can understand why she would be very awkward and unwieldy, and she becomes a prisoner in the colony because the entrances by which she came into the colony are now too small to permit her to escape. Now, here we have preserved termite queen, an actual queen from the tropics. We might call her the African queen, Earl. And you can see how enormous she is. All this big portion here is the abdomen of the insect.
Where's the head? I can't
the
see
head
it.
and the thorax are up here. And this African queen is reputed to lay maybe 80,000 eggs a day.
Well, I know in some of the colonial insects, Dick, there will be a secondary king or a queen developed now. Do you have the same thing in the termites?
Yes, in the termites, if something should happen to the queen, then one of the nymphs would develop into the terminal reproductive caste. But normally, barring accidents, a queen will live a long time, maybe 20 years. Workers' normal lifespan is probably around 4.
About 4 years. Of course, with the queen producing thousands of eggs a day, why, very soon the galleries and the channels in the wood are all filled up, and then the colony has to expand. But in the meantime, they produced a series of very beautiful galleries, as we see here.
Yes, now we might consider termites as divided into two types. The wood-dwelling termites and those that live in the soil, or the subterranean termites. Now, the wood-dwelling termites are further classified into those that are dry wood termites, those that live in dry, sound wood. And then there are damp wood termites, which, as the name would suggest to you, live in damp and rotting wood.
Well, since they live primarily on wood or other materials that have cellulose in them, these subterranean types have to have access to wood someplace.
That's true. Now, their tunnels usually begin where there is wood on or near the level of the soil. And, of course, they may go down into the soil quite a ways. These subterranean termites are the ones that really are the greatest menace to us here in this country. They cause more damage to our buildings and houses than do any of the other types of termites.
But contact with the earth doesn't necessarily mean that the wood is resting on the ground. In other words, sometimes these fellows can build vertically without any support at all and run up mud tunnels, such as we see here. Very beautiful demonstration, still no support.
Yes, that's right. And they can even build vertical structures with runways inside, about the diameter of a pencil, that go way up in the air. And then in Australia, there is a very amazing termite. It's called the compass termite. And it builds these nests that sometimes reach a height of 8 to 12 feet. And the odd thing about them is that invariably these nests are oriented in a north-south direction. The sharp edges of that slab point north and south. And we think that's so that the smallest surface will be exposed to the hot tropic noon sun.
Well, I've examined some of those Australian termite mounds, and I can remember on some of these North Australian airfields a minor hazard coming in on the runway, so these various termite mounds off at the side.
That's interesting.
Well, now, is there any special reason that these things are able to develop this? And going into the thing architecturally speaking, of course, in Egypt we have the pyramids, but here are insects that do things that are much greater even than the pyramids.
Well, we don't know really how they figure these things out. In the tropics, there are certain tree-dwelling termites which put eave-like coverings over their nests so that the tropic rains coming down the trunks of the trees will be diverted. And similarly, there are subterranean termites there in Africa which build large nests in the ground and cover them with a cap. They look like giant mushrooms or toadstools. And, of course, that cap sheds water just like an umbrella would.
Well, as far as anyone knows, termites don't go to sleep, and they work around the clock 24 hours a day so that they can do a great deal of damage in that period of time.
Well, that's right, and oddly enough, Earl, in spite of all the wood that termites consume, some species are unable to digest any part of it. And to help them in this regard, they have in their intestines little animals which we call protozoa. And the termites would actually starve without these protozoa, and of course the protozoa are equally dependent upon the termites. And I think maybe we can see some of those. If we make a little dissection here, we'll put a drop of water on the slide. We'll get a termite out here, and we'll examine the contents of its abdomen. Now, I think if you will turn on that switch there on that microscope,
right here,
Earl, we'll soon have this ready, and we'll see that there are many of these little multicellular animals. Are very bizarre shaped. Get them in focus here. I think that you'll be very interested in seeing what they are shaped like.
In other words, this is the thing that has to be in the digestive tract of the termite for him to be able to live.
That's right, Earl.
And I can see there's some vibration there. Now, each one of these is an individual organism in itself, and that is the thing then that changes the cellulose into a form that the termite can make use of.
That's right. It makes it available to him.
Mm-hmm. Well,
now,
really
the young termites, of course, are not born with that. They're fed pre-digested food, and that's how they get the protozoa into their intestines.
Well, I'd like to point out a very interesting situation that occurs in the Nile River bottom. Over there is a large lizard called a monitor lizard. And these monitors have a unique custom. They lay their eggs inside of the termite nest, and the termites, for some reason, allow the eggs to stay there. And when the eggs are hatched, the young lizards have a ready food supply. So it's quite a peculiar arrangement, and that's one of the monitors in the Nile Valley that has that strange custom.
Well, in spite of these enemies that termites have, they're really pretty successful insects, Earl, and that's probably the reason why they cost us maybe as much as $80 million a year in this country. And really, the way to avoid damage from termites is to build in such a way as to discourage them. First of all, it's necessary to have a good concrete foundation, but this in itself is not necessarily a complete safeguard because termites will sometimes build these passages up the side of the concrete, as we mentioned before, until they reach up into the timbers, which are very vulnerable. There you see that passage is broken open, and you can see the termites busily crawling around in it, and they will repair that break.
Well, if you want to be absolutely sure, then, or one thing you should do under your house is to make sure that you don't have any pieces of debris or old lumber that have been left under there. There are other ways, of course, of using creosote. Sometimes it's put on the outside of the lumber, but to be absolutely certain again, it should be pressure impregnated in order that the termites will not go through that outer shell and then get into the inside of it.
Yes, that's good advice. And you know, Earl, in most property owners that live in areas that are where termites are prevalent, we might indicate to them that if they find over these concrete foundations, these little tunnels, that indicates the presence of subterranean termites. But should they find these little piles of pellets around windowsills or perhaps along the floor, they would know that they had drywood termites in their building.
Of course, one way that you can check the underside of your foundation is just with an old ice pick and a flashlight, and then you go around with the ice pick underneath the house, and anywhere that ice pick accidentally goes through onto the, as it did here, well, then you know that there's something you're going to have to check on. Two things are involved. It might be a fungus injury. In other words, dry wood sometimes has the same appearance, but if it happens to be a termite injury, then you may wish to call in a termite man for some additional help.
Well, here we see a termite control man or a pest control operator at work. After making a search and locating the presence of these insects, the thing to do is to remove, of course, the weakened parts, the members in the house that are structurally weakened, such as this piece here. Now, you can see that there's no strength left in that timber at all. It comes off very easily right into his hand. And this can be very extensive in some buildings. Why, that is really a graphic
Somebody's going to have a lot of
demonstration
work to do, I should say.
the damage that termites can do. Now, one way that we can repair termite damage is to consider the normal construction in a house. This little model, Earl, will show that here has been a good solid concrete foundation laid down, the mud sill and the studding, and then the floor joists up here. But in spite of proper construction, sometimes soil will build in and up above the concrete foundation. And as you mentioned before, debris will sometimes get in along the mud sill, and that just invites termites to injure all this portion in here.
Well, then perhaps the way to fix it would be to put in some more cement in here. In other words, remove all the old timbers and pour some additional concrete in this section so that the result then, when the two of them are compared side by side, would be something like so.
That's right, and if you had an extensive repair to do like that, you would appreciate what an expensive business it is to feed termites at times.
Of course, termites do all sorts of peculiar damage, and we have some of them here. If you happen to keep your cooking recipes in something like this, I think you get a shock when you opened it and found that things were in a bit of a jumble. Or perhaps books. Look at this. Let's see, what is this? This is the Philosophic Nights in Paris. And termites didn't seem to like it, and so you can see what they've done there. Oh, yes, here's something else, a very beautiful picture that used to hang on the wall. Now it is of interest only to the biologist because it demonstrates what termites can do. Just one other thing, Dick, that I'd like to mention. Redwood is often good to use structurally because it has tannic acid in it. But after that tannic acid is leached out and the wood has been there for a long time, then the termites will attack it, as we see here.
Well, there is one habit that termites have which we can exploit in their control, Earl, and that is this habit of licking and grooming each other. I think here in this close-up of the termites, we can see how they may be doing that. Now, if the infestation is not too extensive, you can insert into the galleries a poisonous dust which is picked up on the termites' bodies, and then in this licking and grooming one another, they transfer it among the whole colony and, of course, are poisoned and die out. Now, when the infestation is very extensive, particularly with drywood termites, the best control method is probably to use fumigation with methyl bromide. And then other control methods and modifications of them can be applied to termites also.
Usually, of course, there's little indication on the outside as to what has been happening. This picture molding is a good example of that. We open it up, and we see that here we have a shell that's been left. Now, this matter of detection, getting back to something that's just come out very recently, Dick, the microsonic detector, this little gadget which we have here, which Roy Pence at UCLA, together with the Craig Electronics group, have developed to tell how termites act inside of something. How does it work?
Well, I think we can try it here, Earl. It has this sort of stethoscope arrangement that you put on your ears.
Oh, good.
And then we can turn up the gain control here, and we put this sensitive probe over here on this log where there's some termites inhabiting it. And can you tell me what you hear now?
The patter of little feet, or perhaps I guess it would be the soldiers clicking their bodies one against the other, or hitting the sides of the tunnel. Suppose we try something here, Dick. Perhaps if we can drop this sound boom down.
All right, I'll
put
turn
this
up
here.
the gain
Oh,
here.
yes, the volume, and we'll see what happens now. Perhaps we can get some of this sound coming out over the... Well, there it is. Say, that's quite a noise.
Yes, well, of course, Earl, this is a very special demonstration because we know that there are only termites in this particular piece of wood. And the investigator must learn to distinguish between the noises that termites make and the other sounds that he's going to pick up with this very sensitive device.
Well, I hope you'll loan me this for a couple of days before we have to send it back to UCLA. And I want to say, Dr. Dow, thanks once again for coming to our laboratory. Oh, and be sure and count all your termites, too, will you, please?
All accounted for.
Oh, fine. I'll be back in just a moment with the Animal of the Week. Attempting to find information on Animals of the Week is not always easy. Take, for example, the monkeys. A lot of data, but it's in scattered publications. At least that was the case until just recently when a new book came out, The Monkey Book by Ernest P. Walker, who is at the National Zoo in Washington. We've been having a lot of fun going through this book, looking at various kinds of monkeys that we have and haven't had on the program. Here's one, the crested ape of Sotheby's, one of the strangest things I've seen. I did find something that was quite interesting here, and that is the fact that among our American monkeys, the type that makes the best pet is the woolly monkey. Now, in the wild, these monkeys live in troops of a dozen or more high in the trees, and they feed mainly on fruits and leaves. They're less active than the other monkeys, and so as a result, they generally make better pets in captivities. Now, we have a special woolly monkey that's been brought to our laboratory by John Evelyn, and this is really a cute little fellow. John, about how old is Jimmy at the present time?
Well, Doctor, Jimmy is 18 months old.
18 months. He's certainly an aggressive little rascal. Can you come up here for a minute, Jim?
Come up here and see me? Come on up and see me. Will you do that? Well, come on up and see me.
Put your arm.
That's the boy. That's the boy. I noticed that prehensile tail. Now, is that characteristic of these woolly monkeys?
Yes, that is characteristic of most of the New World monkeys. The Old World monkeys have the pouches, cheek pouches, and not the prehensile tail.
What do you have in your pocket there? Perhaps we can try and see how he likes food. I know he likes
Well, maybe.
rascal quite a bit.
Maybe he'll get in there and... Here.
You like some peanuts, boy?
You like some peanuts?
Now, even the males
He'd
among
like to
this...
take them out
we
himself.
will? You'd like to take them out? Even the males, I understand, in these woolly monkeys are very good pets.
Yes, they're very gentle. Even the adult male is gentle as a kitten. He likes to play just like a...
Jimmy's never been on
small
television before, and he doesn't know he's supposed to eat these peanuts. Well, let's see if we can pick him up here, John, for just a moment, and I hope you'll keep us advised as to how Jimmy does in the future. He's certainly a little rascal. Thanks very much for bringing him to Science in Action. Boy, he is really all over the place, isn't he? Well, thanks.
He's played quite quick.
Thanks a lot, John. Now, this is pure oxygen. You can't see it, you can't taste it, you can't smell it, and yet it's there. And on our next program, we will be concerned with the problems in the field of the use of oxygen. Our special guest at that time will be Dr. Charles Wyckoff. We hope that you will plan to be with us then. Thanks a lot.
You have just seen another in the fascinating television series, Science in Action. Science in Action is produced by the California Academy of Sciences under the supervision of its director, Dr. Robert C. Miller.